This video is the example video that goes along with balancing redox reactions. So in this video, we'll be looking at examples 1 and 2 out of the notes. So before we work through the examples, I just want to look at kind of a quick summary of balancing redox equations because this is different than balancing just regular chemical reactions. Redox is important because we have transfer of electrons, and so we have to balance it in a special way to make sure that we're taking into account those electrons being transferred from the reduction and oxidation half reaction. So again, before we even look at these steps, remember that in order to determine if something is redox, you need to assign oxidation numbers. So assign oxidation numbers to everything. If the oxidation numbers don't change, then it's not redox and you won't even balance it like this. Once you know that it is redox and you're looking at starting to balance, when you balance the elements other than H and O, you balance it just like normal, put coefficients out front. But then when it comes to balancing hydrogen and oxygen, you have to do that in a special way. And so what we're going to do is use water to balance the oxygen. So the order of your balancing is balance all atoms except for H and O, then balance O, then balance H. And so we'll use water to balance oxygen. So never add oxygen atoms or O2 minus ions or O2, anything like that. You always just use H2O to balance oxygen. Once you balance the oxygen, then you have to come to the hydrogen. And to balance the hydrogen, you use H+. So no matter what, whether it is acidic or basic, you'll always balance it this way, and then I'll talk about how it's unique if it's a basic solution at the end. So you always will balance hydrogen using only H+. Never just H, never H2, only H+. And then after you've balanced all of the atoms, it comes to the electrons. So the number of electrons in each half reaction should reflect the change in oxidation number. So think Leo the Lion says grr or oil rig. If it's oxidation, then the half reaction is losing electrons, and so the electrons will be on the product side. If it is reduction, that means that the substance is gaining electrons. So just like an endothermic reaction, when it's gaining heat, it's on the reactant side. So in a reduction half reaction, we should see electrons on the reactant side. The electrons should always be in half reactions, but should never, ever be in the overall equation. If you have electrons in the overall equation, something went wrong. You should never see them in the overall equation. Make sure that you're always including charges. So if you have an ion or you have like a polyatomic ion, make sure that you're still always showing charges. And then the best way to balance redox is just to work through practice because this is different. So let's look at example 1. So example 1, we have the dichromate ion plus the chloride ion yields Cr3 plus Cl2. And notice it says in acidic solution. Example 2, we'll be looking at a basic solution, so we'll be looking at how that is different. But for this one, we're looking at in acidic solution. So remember to start, you always want to assign oxidation numbers. So I want you to take a second, pause the video, and assign oxidation numbers to every individual element or ion in this equation. So once you assign oxidation numbers, you should find that each Cr is +6, each O is -2. Remember that oxygen always carries -2 unless it is the only thing with fluorine or if it's a peroxide. Peroxide is O2, 2-. So each chromium is +6, each oxygen is -2, and then Cl- has an oxidation of -1. Then we come to Cr3+, so that carries a +3, and then Cl2, that is in its elemental form, and so that's going to be 0. So once we assign the oxidation numbers, then we have to look at each half reaction. And so when we look at the half reaction, we are only looking for the atoms that change oxidation number. So if you notice, Cr is going from +6 to +3, and Cl- is going from -1 to 0. Don't worry about the number of atoms, anything like that, that comes out in balancing. So the first step is to write the half reactions. So the oxidation half reaction is Cl- becoming Cl2. because in order to go from -1 to 0, it has to lose electrons. Remember that electrons are negative. And so it has to lose electrons to go from a -1 to a 0 oxidation number. The reduction half reaction will be Cr2O7 2- becoming Cr3+. When you're writing the half reaction, you have to make sure to take the entire substance. So even though it's just chromium going from +6 to +3, you still need to include the entire dichromate ion as the reactant. And that's a reduction half reaction because chromium is going from +6 to +3. Its oxidation number is reducing because it's gaining electrons. Electrons are negative. So once you've written the half reactions, then you're going to balance all of the atoms except for O and H. And so when we look at the oxidation half reaction, I have 1 Cl on the left and 2 on the right. And so I need to put a 2 out front. For the reduction half reaction, I have 2 chromiums in the dichromate ion and only 1 on the product side. So we need to put a 2 in front of Cr3+ on the product side. So now we've balanced our atoms except for O and H. So once we have those balanced, then we're going to balance for oxygen by adding water. And so make sure that when you're balancing oxygen, you're adding water. Now in the oxidation half reaction, there's no oxygen. You don't have to worry about it. In the reduction half reaction, we had oxygen on the left and we didn't have any on the right. And so since we had 7 oxygens on the left, we needed to add 7 waters to the right. You have to balance oxygen by adding water. And so we had 7 oxygens in the water, and then you balance hydrogen because there's hydrogen in water. So by adding 7 waters, that's 14 H's on the right side, which means we need 14 H pluses on the left. So balance oxygen by adding water, balance hydrogen by adding H plus. And then the fourth step is to balance for charge. And so when you're balancing for charge, it's always about adding electrons. Redox is all about adding electrons. That's it. So when we look at the oxidation half reaction, we have 2 Cl- and we have 0 on the right. So we have 2- on the left, 0 on the right. So when you're thinking about adding electrons, you need to add the electrons to the more positive side because electrons are negative. And so we're going to add 2 electrons to the right. So the oxidation half reaction, notice, remember Leo-Ger. Lose electrons is oxidation. So the oxidation half reaction loses electrons. So that should make sense. When we look at the reduction half reaction, so on the reactant side, we have -2 plus 14. So on the left side total, we have +12. And on the right side total, we have +6 because we have 2 of the chromiums. So we have +12 and +6. So we have to add the electrons to the more positive side to balance out the charge, which means we need to add 6 electrons to the left. Remember that reduction is when you gain electrons, and so the reactants are gaining the electrons. Notice how the electrons are on opposite sides. You always need to make sure that the electrons are on opposite sides, because if one of the half reactions is losing, that's because the other one is gaining. And once we have our charge balanced with electrons, we have to make sure that they are equal. We have to make the electrons equal because when we add the half reactions together, we need to make sure that the electrons can cancel. And so if we look back at step 4, we have 2 electrons and 6 electrons. So think about what we can make them both equal for them to cancel. Well, a common multiple of 2 and 6 is 6. And so what we can do is we can multiply the oxidation half reaction by 3, just like you would do with Hess's law. If you want to multiply this by 3, you have to multiply everything by 3. The reduction half reaction we can keep the same. So when we multiply by 3, we get 6 Cl-, 3 Cl2, and 6 electrons. We keep the reduction half reaction the same. Notice now they're both 6 electrons. So then the final step is to add the half reactions together and cancel anything that appears on both sides. So if we look at both of these half reactions, and sometimes it helps to line the arrows up, we'll notice that here when we add these together, the only thing that is the same are these 6 electrons. Remember that your electrons should always cancel. So when you write the overall equation, we should not see electrons anywhere in here. Now you can double check once you've canceled and make sure everything is still balanced. So notice 2 CRs, 2 CRs, 7 O's, 7 O's, 14 H's, 14 H's, 6 Cl, 6 Cl. So the atoms are balanced, and if you check the charge, you should notice that the charges are equal as well. So we have -2 plus 14, so that is plus 12, minus 6, that's plus 6. So the left side is plus 6, the right side is also plus 6. So that is looking at balancing a redox reaction using this half reaction method. Example 2 now has us look at a reaction in basic solution. So in this example, we have ClO minus plus CrOH4 minus yields CrO4 minus plus Cl minus. So remember, the first thing you always want to do is assign oxidation numbers. So take a second, pause the video, and assign oxidation numbers to each individual element in this. When you assign oxidation numbers, you should find these oxidation numbers for each element. Notice how, even though normally we're used to Cl being minus, in this case it's +1. The more electronegative atom is the one that will always carry the negative. So since oxygen is always -2, that one's going to be -2, but instead of Cl being +2, it has to be +1 because we have to make the total oxidation equal to the ion's charge. So Cl will be +1. Cr will be +3. Now, an easy, kind of a quick way to find Cr's oxidation is just by remembering that hydroxide, OH, is -1. So if there's 4 of them, Cr must be +3 because the total, everything in this has to be -1. And then you can assign inside of hydroxide. For hydroxide to equal -1, O has to be -2, H has to be +1. Remember that hydrogen is always +1 if it's with a nonmetal. So since hydrogen is directly bonded to the oxygen here, it carries a +1 charge. The only time that hydrogen is -1 is if it's hydrogen and only a metal. So these are the oxidation numbers for each individual element in CrOH4 minus. And then in chromate, Cr is +6, each O is -2, and Cl minus has a -1 charge. Once we have oxidation numbers assigned, it's important to remember that we will balance this just like if it were an acidic solution, except at the very, very end, we will add the OH minus. So these steps that we're going to go through are just like we did for example 1, except at the very, very end. Once we have what looks like the final reaction, we will add the OH minus. So the first step is to write the half reaction. So if we look at how the oxidation numbers change, notice how oxygen doesn't change. Oxygen normally doesn't change. Cl goes from +1 to -1. Cr goes from +3 to +6. And so when we write our half reaction, that means that if chlorine is changing, we'll write ClO minus, yields Cl minus, and then CrOH4 minus yields CrO4 minus. So the oxidation half reaction is the one that involves chromium because chromium is going from +3 to +6. So it is being oxidized. Its oxidation number is increasing because it's losing electrons. And then the reduction half reaction is the one that includes chlorine because chlorine's oxidation number is reducing from +1 to -1. So the first step is just to write the half reactions. Once we have the half reactions, we need to balance every atom except for O and H. And in this case, they already are. 1 Cr, 1 Cr, 1 Cl, 1 Cl. Once we have all of the other atoms balanced, then we balance for oxygen, and then we balance for hydrogen. Remember that to balance oxygen, you need water, and to balance hydrogen, you need H+. It's fine that this is basic solution. You still have to balance hydrogen using H+. So the oxidation half reaction, if we have CrOH4 minus, we have 4 oxygens. We already have 4 oxygens, so that's okay. We don't have to actually add water. We have 4 hydrogens on the left, which means we need to add 4 H+ to the right. So this is the oxidation half reaction. The reduction half reactions start with oxygen. So 1 O, initially we had 0 oxygens, which means you need to add 1 water. And then by adding the 1 water, you've added 2 hydrogens to the right, and so you're going to add 2 hydrogens to the left. So that's how we balance all of the atoms. So now we have all atoms balanced. Now we balance charge. So if we look at the oxidation half reaction, we have a total charge of -1 on the left. We have a total charge of +2 on the right, because we have -2 and +4. You have to add electrons to the more positive side because electrons are negative. So what we will do is we will add 3 electrons to the right because it's -1 + 2. Remember that electrons are negative. Oxidation, you should always be adding electrons to the product side because it will lose. If you just double check when you write your electrons. So if this is -3 and -2, that's -5 + 4, -1, -1 on this side. So the charge in the oxidation half reaction is balanced. The reduction half reaction, we have -1 + 2, and then just -1. Add the electrons to the more positive side. So when we add 2 electrons, that becomes -3 and +2, that's -1, and then -1. Notice how the electrons are added to opposite sides. If you add the electrons to the same side, something went wrong. Go back and double check. Once we have our charges balanced, then we have to make sure our total number of electrons are equal, because the whole point of balancing redox is to make sure that the transfer of electrons is equal so that we can cancel them out. So if we have 3 electrons in the oxidation half reaction and 2 electrons in the reduction half reaction, what's a common multiple of both of them? 6. So we need to multiply the entire oxidation half reaction by 2, the entire reduction half reaction by 3. So when we multiply the oxidation half reaction by 2, we can write out our new half reaction, and notice that gives us 6 electrons. Do the same thing with reduction. Multiply everything by 3. Notice it gives us 6 electrons. So once we have our total number of electrons balanced, then we add them together and we cancel anything that is the exact same on both sides. So when we add these together, and again, sometimes it helps if you line the arrows up, like one on top of the other, just to help you see. So notice that our 6 electrons cancel. Electrons should always cancel. Sometimes they're the only thing that cancels. Other times you have other things that cancel. So if you notice in blue, we have 8H plus and 6H plus. So what we can do is at least cancel out 6 of the H plus, and that will turn this into a 2. And then we add them together. So when we add them together, we get this new reaction. So we get 2 CrOH4 minus plus 3 ClO minus yields 2 CrO4 minus, 2H plus, 3 Cl minus, and 3 waters. Now, if this were in acidic solution, this would be it. This would be our answer. But because it says that we are in basic solution, you should not see H plus. H plus tells you that it's an acid. But if it's a base, we shouldn't see H plus. And so what we have to do is we have to neutralize this H plus. And to neutralize H plus, just like we looked at in acids and bases, you add OH minus. So if we have 2H plus, we need 2 OH minus. But if you're going to add it to one side, just like in algebra, you have to add it to the other side as well. So that means that we have to add 2 OH minus to each side. And when we add 2 OH minus to each side, what that will do is that will create water. So when we have 2H plus 2 OH minus, that will give us 2 waters, because a neutralization reaction is simply H plus OH minus yielding H2O. And so then you can combine like terms. So you can always combine like terms. So when you have 2H plus 2 OH minus, that becomes 2 water. So the final equation that's balanced for atoms and charge becomes this as written. And notice we have 2 OH minus on the left, and then that gives us 5 H2O on the right. So again, when it's basic solution, you have to neutralize with OH minus. And so the 2H plus on the right combine with 2 OH minus to make 2 waters, and then we can combine the like terms, which gives us the 5 waters on the right. So the best way to work through Balancing is just to practice, 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 practice. And there is a practice video that goes through the balancing half reactions sheet in your notes. So use that as well. And then you can try the last balancing on your own and check answers.